Look up at the night sky. It's a vast, endless canvas, scattered with countless points of light. Each one has a story to tell. Each twinkling light is a star, a sun like ours. Some are close, some unimaginably far away, but all are burning with energy. Our sun feels enormous, dominating our sky and powering life on Earth. But in the grand scale of the universe, it's actually a lightweight, a rather ordinary star among billions. Out there are the true titans, supergiant stars. These are the giants that truly push the limits of what a star can be. What makes a star a supergiant? It's all about mass and size. These stars are in a league of their own, far surpassing ordinary stars in every way. These stars are born with at least 8 to 10 times the mass of our sun, sometimes much more. Some can be up to 100 times as massive, making them true cosmic heavyweights. All that mass creates immense pressure and heat at their cores, making them burn through their nuclear fuel at a staggering rate. Their surfaces are turbulent, alive with storms and flares. This furious burning causes them to swell to hundreds or even thousands of times the size of our sun. Their outer layers balloon outward, making them some of the largest objects in the universe. They are the most luminous, most massive, and largest stars in the universe. Their brilliance can light up entire regions of space, outshining everything around them. Imagine our sun as a grapefruit. A supergiant on that scale could be as large as a football stadium. The difference is almost beyond comprehension. Some are so vast, their outer layers would swallow Mercury, Venus, Earth, Mars, and even Jupiter. Our entire solar system could fit inside a single supergiant. These giants live fast and die young, lasting only a few million years. Compared to our sun's billions of years, their lives are over in the blink of a cosmic eye. Their lives are short, brilliant, and end in spectacular explosions. When a supergiant dies, it does so in a blaze of glory. When they die, they outshine entire galaxies. For a brief moment, a single star can be brighter than billions of others combined. In their death, they seed the universe with the ingredients for life. The elements forged in their cores are scattered across space, becoming the building blocks for new stars, planets, and even life itself. They are both creators and destroyers. Their existence shapes galaxies, and their deaths spark new beginnings. Supergiants are the rock stars of the cosmos, burning bright, dying young, and shaping the universe in ways we are only beginning to understand. Their story is our story. The atoms in our bodies were once inside a star like these. Let's meet these cosmic behemoths and discover how their epic lives connect to our own. Meet Betelgeuse, the bright reddish-orange star that marks the shoulder of Orion, the legendary hunter in the night sky. For centuries, stargazers have marveled at its striking color and prominence, making it one of the most recognizable stars above us. Betelgeuse is about 640 light-years away from Earth, meaning the light we see tonight actually began its journey during the early Renaissance, long before telescopes were invented or the modern world took shape. This star is a true giant among giants, a red supergiant swollen to nearly 1,000 times the diameter of our sun. If you could line up almost 1,000 suns side by side, Betelgeuse would still be larger. If Betelgeuse replaced our sun at the center of the solar system, its surface would stretch far beyond the orbit of Mars, possibly even reaching out to Jupiter, engulfing the inner planets in its fiery embrace. Betelgeuse is so immense that, unlike most stars, astronomers have actually managed to image its surface directly with powerful telescopes, a rare achievement in stellar astronomy. But Betelgeuse is not a steady beacon. It pulsates, brightening and dimming over months and years, as if it's breathing in and out, hinting at the turbulent forces within. In 2019 and 2020, Betelgeuse dimmed more dramatically than ever before, an event astronomers called the Great Dimming, which captured headlines and sparked global curiosity. Some wondered if this was the prelude to a spectacular supernova explosion, but the cause was a massive ejection of gas and dust, temporarily veiling the star from our view. Still, the show isn't over. Betelgeuse is living on borrowed time, its life nearing a dramatic finale. Within the next 100,000 years, a blink in cosmic terms, it will explode as a supernova, lighting up our sky with a brilliance never before seen by modern humans. When that day comes, Betelgeuse will outshine the full moon for weeks, casting eerie shadows at night and captivating everyone on Earth. Betelgeuse is a cosmic time bomb, a reminder of the universe's awesome power and the ever-changing nature of the stars above us. Its fate is sealed, and as we watch, we're witnessing history in the making, an unfolding story written in starlight. One day, Betelgeuse will go out in a blaze of glory, its death marking the birth of new cosmic wonders. Until then, it remains a living legend in our night sky, a beacon for astronomers and dreamers alike. So keep an eye on Orion's shoulder. The universe's next great show could begin at any moment, and you won't want to miss it. Now, let's travel south to Eta Carinae, a star system like no other, hidden deep in the southern skies. This mysterious object has fascinated astronomers for centuries, drawing their gaze with its unpredictable brilliance and strange behavior. Eta Carinae is actually a system of at least two stars, with the primary being a luminous blue variable, an absolute giant, over 100 times the mass of our Sun, and shining with the light of 5 million suns. Its companion is also massive, but the primary dominates, radiating energy at a staggering rate. In the 1840s, Eta Carinae underwent a spectacular eruption, suddenly becoming the second brightest star in the entire night sky, outshone only by Sirius. This outburst was visible to the naked eye and startled skywatchers around the world. Yet despite its dramatic increase in brightness, it didn't explode as a supernova. Instead, it survived, earning the nickname Imposter Supernova for mimicking the explosive finale of a dying star without actually dying. The eruption blasted out the Homunculus Nebula, a striking dumbbell-shaped cloud of gas and dust that now surrounds the star system, glowing eerily in the darkness. The nebula contains enough material to make dozens of suns, all ejected in just a few years, a cosmic storm of unimaginable power and scale, reshaping the region around Eta Carinae. Even today, Eta Carinae remains unstable, shedding mass, and constantly reshaping its environment. Its powerful stellar winds and eruptions continue to sculpt the nebula, making it a dynamic and ever-changing spectacle. It's a ticking time bomb, likely to go supernova, or perhaps even hypernova, at any moment. When it finally explodes, it will be one of the most spectacular events ever witnessed from Earth. Studying Eta Carinae helps us unlock the secrets of the violent lives and deaths of the universe's most massive stars, offering clues about how these cosmic giants shape galaxies. It's a cosmic laboratory for stellar death, a place where astronomers can observe the forces that tear stars apart and create new elements for the universe. The final experiment could begin at any moment, and when it does, it will change our understanding of the cosmos forever. Eta Carinae's story is far from over. Its next chapter could be the most dramatic yet. Meet VY Canis Majoris, a red hypergiant, once considered the largest known star. Located 3,900 light-years away, it's about 1,400 times the diameter of our Sun. If our Sun were a door, VY Canis Majoris would be a mountain. A spaceship at light speed would take over 6 hours to circle it. If it replaced our Sun, it would engulf the orbits of Mercury through Jupiter. VY Canis Majoris is highly unstable, surrounded by a chaotic nebula of ejected material. It's violently tearing itself apart, losing mass at an incredible rate. Some astronomers think it might collapse directly into a black hole. VY Canis Majoris pushes the limits of how big and unstable a star can get. It's a monument to the extremes of the cosmos. Now meet the king. UY Scuti, the largest known star by diameter. Located near the Milky Way's center, it's a red hypergiant with a radius about 1,700 times that of our Sun. Its diameter is 1.5 billion miles. So big, it would extend beyond Jupiter's orbit. The volume of UY Scuti is about 5 billion times that of our Sun. A commercial airliner would take over 1,200 years to circle it once. UY Scuti is a variable star, pulsating in brightness every 740 days. Its outer layers are so diffuse, it's more like a hot vacuum than dense plasma. Despite its size, it's only about 7 to 10 times the Sun's mass. The biggest stars aren't always the most massive. UY Scuti is swollen and unstable, nearing the end of its life. Soon it will explode in a supernova, lighting up the galactic center. It's the ultimate cosmic heavyweight. How do stars get so enormous? It starts in stellar nurseries, vast clouds of gas and dust. Gravity pulls material together. If enough mass gathers, nuclear fusion ignites, and a massive star is born. Massive stars live fast, burning through fuel at a furious rate. They shine millions of times brighter than our Sun, but only for a few million years. Once hydrogen runs out, the core contracts and the star swells into a red supergiant. The core fuses heavier elements: helium, carbon, neon, oxygen, silicon, layer by layer. Each stage is shorter and more frantic than the last. The star becomes a layered, onion-like structure, but this process can't go on forever. Eventually the core reaches iron, and that's the beginning of the end. Supergiants live fast, die young, and go out with a bang. Their short, furious lives shape the universe. When a supergiant's core turns to iron, fusion stops releasing energy. Gravity wins. The core collapses in less than a second, shrinking from planet-sized to city-sized. The outer layers crash down, rebound, and a shockwave rips the star apart in a Type II supernova. For weeks, the explosion can outshine an entire galaxy. It releases more energy in moments than our sun will in its entire life. The supernova forges elements heavier than iron: gold, silver, uranium. These elements are scattered across the galaxy. The supergiant's death seeds the cosmos with the raw materials for new stars, planets, and life. It's the universe's most spectacular finale. After the explosion, the star's outer layers form a beautiful supernova remnant, like the Crab Nebula. The core's fate depends on its mass. If it's between 8 and 20 solar masses, it becomes a neutron star, a sun's mass crushed into a city-sized sphere. Some neutron stars spin rapidly, emitting beams of radiation. These are pulsars, the universe's most precise clocks. If the core is even more massive, it collapses into a black hole, a point so dense, not even light can escape. The ghost of the star remains, consuming anything that comes too close. Supernova remnants and their cores are cosmic relics. They shape galaxies and drive cosmic evolution. The end of a supergiant is just the beginning of something new. Supergiant stars may seem distant, but their story is our story. The universe began with only hydrogen and helium. Every heavier element, the carbon in our bodies, the oxygen we breathe, the gold in our rings, was forged in stars. The heaviest elements were created in supernova explosions. These elements seeded new generations of stars and planets, including our own solar system. The iron in your blood and the calcium in your bones were made in ancient supergiants. We are literally made of stardust. We are the children of supernovas. The titans of the universe died so that we could live.